And we are live. Okay, I'm gonna stop right now and ask, why do I say that? This is a video. Why do I say we're live? Videos, by their very nature, are not live. Okay, so we're not live. We are videotaping. Or we are watching a video that was made 100 years ago. Hello, people 100 years in the future. I hope people are still watching it then, because of course, today's topic is the system of coordinates, the coordinate plane, tables of values, x-axis, y-axis. It's interesting stuff, it's math, and it's been here for a while, and it will be here 100 years into the future. And that is interesting to me. Okay, what's going on? I don't have any beautiful assistant dog with me this time. It's still boring October cold weather. I'm cold. Why am I wearing my West Ham jersey? Because this West Ham jersey, like my other two, I have 3 of them, they're the only ones I have that are actually made of kind of a flannel. And they're warm, which is good because I'm in the basement, I'm wearing slippers, and I'm cold. Okay, let's get into the math though. This is kind of gonna be an easy one. I like to say that, even though, well, if it's an easy one, is it going to need a whole hour of a lesson? Yes, because while it's something that I think the students will find easy, it's extremely important. And I think it's a natural mistake when you think something is easy to just practice it for 5 seconds and say, oh, I know that, and walk away. And that could cause problems. Because while this is kind of easy stuff, and it's kind of artistic-y and drawing-ish, and it's fun in a lot of ways, it's extremely important, and there are a lot of details, little tiny details that matter. When I teach my class of students who usually have already been to high school and are coming back to school, I see what types of mistakes they make in their math. And some of these details reveal that students can have some confusion about this stuff, and then it's a problem from then on, because once you learn this sort of stuff, you need it in all the math you'll do afterwards. Why do we need the coordinate plane? So we can graph things. What do we graph? Well, we graph straight lines in math, but we also graph all sorts of other shapes like parabolas and circles and square root curves and, well, all sorts of curves. We use the word curve to describe all of these shapes, including the straight line. Yes, a straight line is a curve. Okay, I'm babbling. Let's get into it. We need to know the terminology that goes with it. So, this is a system of axes, it's a coordinate plane. This is the x-axis, and this is the y-axis. And it's important that we realize we have 2 axes for a reason. Because the x-axis should look really familiar to students who have learned the math that comes before this but haven't seen this yet. The x-axis looks like a number line, and that's because it is a number line. We are creating a number line for a special purpose, and we're calling it the x-axis. We like to put an arrow over here to remind us that it keeps on going forever. It keeps on going forever in this direction as well, but we don't have to have an arrow over there. And we like to label it with x, because it is possible to twirl this around in some other way so that the x-axis wouldn't be pointing out to the right like this. We want the students, we want the people who look at the graph to know for sure, okay, this is our x-axis, here it is, like where we expect to find it. The y-axis also looks like a number line, but it's a number line that's going straight up and down. And I like that because it reminds me of the thermometer. And thermometers are good because we're familiar with them and we use them a lot. Thermometers are good for helping us to learn, for instance, how to deal with positive and negative integers. Because with thermometers, you can measure positive temperatures, but you can also measure negative temperatures. And that really gives us a feeling for the integers when we're learning them. But this coordinate plane is a combination of the x-axis and the y-axis. So they're both there. And that's interesting. It means that when you want to graph something, like when we graph something on a regular number line, we might want to graph 3. I'll label 1 here, and I'm going to label 1 as well there. I don't want to clutter this up with too many numbers. So if that's 1, that means this is 2, that's 3, that's 4. I have room to put 1, 2, 3, or 4 over on this section of my number line. And when we graph on a regular number line, well, we just have to put a dot on the line. But what we're preparing to do is to be able to graph things that don't only go left and right somewhere along this line, they also can go up, down along this line. So you have a combination, and it gives you a lot more things that can happen. So we can graph all of these points and many others, and you see we have a lot of variety. Some of them have zeros, some of them start with a 0 as the x-coordinate, some of them have a 0 as the y-coordinate, some of them don't have any zeros, some of them have negative numbers, some of them don't. So all sorts of things that can happen, and they will allow us to graph all of these points somewhere around here in these 4 quadrants of the coordinate plane. This is the first quadrant. It's the one that we get used to using the most because it's where we have a lot of positive numbers. So if I'm going to say that, I need to also label a little more. I'm going to label -1 over here and -1 over there. Should I put all the numbers? I think I will, because if we're beginners, seeing the numbers will help us to feel comfortable with what we're doing. So I will put my 2, my 3, my 4, like you expected to see. And over here we have a 2, a 3, and a 4. And then over here and down there we have all the negative numbers. So I'll label those as well. -2, -3, -4. -2, -3, -4. Okay, that's all carefully done. So a coordinate pair is a combination of 2 coordinates, an x-coordinate and a y-coordinate, meaning the x-coordinate, which we put before the comma in the coordinate pair, would go here. I'm writing x, but usually we put a number there. And then the y goes after the comma. So x and y in alphabetical order, the x comes first, and that's the way we do this. It helps us to remember and not get them mixed up. The coordinate pair it tells us how far to go along the x-axis, but it also tells us how far to go along the y-axis. And when we combine them, it allows us to graph points anywhere in this plane and not just along the 2 axes. So I could graph a point over here or over there. The understanding that we already have of integers combined with this setup allows us to do a lot of things. And these things will come in handy when we're graphing shapes, like straight lines, like circles, like all sorts of curves that we will get to use as we move on in our math careers. Okay, what else should I describe? Coordinate pair, the x-coordinate, the y-coordinate, alphabetical order. X is on the left when we do a table like this. If we want to draw a table of values that goes from left to right, we usually put the x on the top, and then it's really the same thing. But I'm just going to use this one for now. And table of values, how is that useful? It's useful in science, for instance, when we do experiments and we want to be able to record results. You could do something like, I'll just give an example, I'm not going to test anyone on this right now. As I give more water to my plants, the plants might grow taller. I might do an experiment where I experiment with giving different amounts of water to a whole lot of plants and then measuring their heights. And I might find that the more water I give the plants, the taller they get, because water is good for plants. So that data, that set of information that is the results of my experiment, can be recorded in a table of values and then it can be graphed. So x might represent the amount of milliliters of water I give the plants, and y might represent the height in centimeters or inches that the plants reach. It's the combination that matters. We're able to see what type of relationship exists between the thing that's our x and the thing that's our y. That's science. That's the way science uses math. It's one of the ways science uses math, and it's very interesting. But we're not going to do it today because we're still beginners. We want to get used to this thing. We need to be able to look at a point that is on the graph. I'll draw one. I'm going to I want to choose one that's not in this table of values, so I'm going to put a point here. I can identify the coordinates, the x and y coordinates of this point, by using my coordinate plane. I can see, okay, well, how far left and right does this point go? From the center, which is the origin. This is the point 0, 0. We call it the origin. It goes 2 to the right of the origin, 2 units to the right. And I can tell that because it's lining up nicely above this little line that is labeled with 2. So that tells me, oh, my x-coordinate must be 2. And then the y-coordinate, well, I'm doing the same thing, but now I'm using this y-axis. I'm going in the up-down direction. So from the origin, I'm going up by 1, 2, 3, and that means that my y-coordinate is 3. So I have identified this point by using the graph, and this worked because the graph is drawn carefully. So if your graph is drawn messy, it's not going to be as easy to use. I was very fussy when I drew this one. I even measured, as I drew the ends of the x-axis, I measured down from the ceiling to make sure that I went the same distance down so that it would really be straight. Because when you're standing close to a chalkboard, it's hard to draw a line that's straight. It looks straight to you, but then it doesn't necessarily look straight to the student or to the camera. So I was very fussy when I drew that line, making sure that it really was straight, and then I was very fussy when I arranged my camera before I started recording this lesson. Normally though, when we do this, we use graph paper. And I don't have a wall that shows graph paper. It doesn't show that grid. And that makes it a little bit more difficult to see what we're doing, which is all the more reason why I needed to be fussy when I drew it. I was really careful, and I was careful to put these little lines proportionally exactly the same distances apart so that we'd be able to identify points and graph points correctly, even though we don't have that grid to help us. Definitely, when you, the students, are practicing with this, use graph paper. Trying to do it on a piece of blank paper like this chalkboard wall is like a piece of blank paper, makes it a little bit more difficult to see what you're doing. All of those corners of the squares in the grid graph paper are helpful to help you find where your points should be or figure out what its coordinates are. Now that I'm coughing, I'm going to take a sip of my fizzy water, because that's always good to have when you are close to a chalkboard with chalk dust. And I will check to see how I'm doing for time, and I'm doing pretty well for time. I don't want to rush through this. I want to take my time and do quite a few examples. Okay, so we are learning both how to identify points like we did with this one, but also how to graph points. So we will graph all of these points. But I want to identify a couple more points first. I'm sort of trying to avoid putting dots too close to all of these numbers in my labeling. So I'll try, for instance, this one. And again, it's hard for me to do this perfectly because I'm looking at it from an angle, but I think I placed that fairly close to where I wanted it. Let's identify it. Okay, so starting with the x-coordinate, that's the first one before the comma. How far from the origin do we have to go, left, right, before we got to this point? We went 1, 2 units to the left. We went to -2 along the x-axis, so its x-coordinate is -2. And then we do the same thing, except with the y-axis, starting at the origin. How far down, because we did have to go down, this point is down below the x-axis, how far down did we have to go to get to this point? We went down -1, -2. The y-coordinate is also -2. Not so hard, kind of fun. Even with these two negative signs, we're still able to do it. Let's do a couple more and try doing them from different quadrants of the plane. How about if I go way over here? Yes, I think I have that in a good place. Let's get our coordinate pair ready. We have to write in our x and y coordinates. Okay, so from the origin, along the left, right, I always do the x first, notice that. I always do the x first. I need to have an organized way of doing it, because if I keep on changing how I do it, it'll become confusing, and I'll be confused. So starting with the x direction, left, right. From the origin, how far am I going? It's pretty clear I am going -1, -2, -3, -4. So even though it's way up here, it still has a negative x coordinate, which is -4. Now let's look at the y. From the origin, this time I'm going up. 1, 2, 3, 4. It has a +4 y coordinate. So here we have a combination of a negative number and a positive number. Here we have the x and y coordinates are both positive, and here they're both negative. And we start to see a pattern emerge, because this is what should happen. When you're down here in this quadrant, you should have a -x and a -y. Over here, you should have a -x but a +y. Over here, the very friendly top right quadrant, we have +x and +y. So what's the only combination I haven't used? We won't be too surprised to see that if I put a point, for instance, right here, and take my time and do it slowly. Along the x direction, I am going to the right from the origin. 1, 2, 3, that is positive 3. My x is positive, and it's positive 3. And then on the y-axis, I am going down from the origin down to negative 1. So therefore, my y-coordinate is negative 1. And the last combination has happened, where the x is positive, the y is negative. We'll get used to this because this is the way it should always be. Positive, positive, negative, positive, negative, 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 positive, negative. It would have been so beautiful if I could have said that without making a mistake. Okay, I'm going to do one more from each quadrant. I'll put all 4 dots, and then we'll gradually, carefully, slowly identify the coordinates. We will identify the points that I am going to put. So I want to put one here. I'm going to put one, how about here? Over here, I've got a lot of clutter. I have to be careful. I think I will put it down here. Again, I'm amazed at how hard it is to do this without it getting all crooked. I hope it doesn't look too crooked on the video, but I'm being careful. I didn't want to draw a coordinate plane and erase it and draw another one and erase it. I would have spent the whole lesson drawing, so I'm trying to use this one so that I don't have to keep erasing it. I can erase points, but I don't want to erase the x and y axes. And one more, let's see. Looking for an interesting spot I haven't used. I think I'm just going to go for this one. And now we will put the brackets with the commas so that we can identify all 4 points. And we'll think about the patterns that we noticed. Let's start over here. We start somewhere that feels easy, and this area with a lot of positive numbers should feel easy. All of them are easy, but lots of positive numbers might feel the easiest. Okay, so this one, I see from my pattern that I expect it to have a positive x and a positive y coordinate. And that looks like what's going to happen. It happened here. So how far did I have to go from the origin left, right to get to this point? I went to the right by 1. That is a positive 1. And then how far did I have to go to get to that point from the origin in the up-down direction? I went up by 1, 2. It is a positive 2. Yes, both coordinates are positive. That's what we expected. We have the point 1, 2. We have identified the point. Let's do this one. From along the x direction, left, right, we go to the left by 1, 2, 3 to get to that point. That is going to be negative 3. Ooh, this is hard for me to draw. Okay, careful, slow down, be careful there. And then how far do I have to get from the origin in the up-down direction to get to this point? I'm only going up by 1. That is a positive 1. We have the coordinate pair negative 3, 1. And does that make sense? Does it jive with the pattern we saw? Yes, it does. We keep on seeing in this quadrant a negative x and a positive y. Are we getting used to this? I bet we're getting used to this. Is it looking as difficult as it did when you first saw it? I hope it looks less difficult because now you start to see, okay, well, like everything in math, there's a process to follow. And you have to slow down when you're a beginner and follow the process carefully. And as you practice, it becomes more and more clear. You remember it better and better. You see the patterns emerging, and then things make sense, and that helps us learn. Over here, we are going in the left-right direction. We are going to the left by 1, 2, 3. That is negative 3. So it is going to have negative 3 as its x-coordinate. And then this point, I'm going down quite far from the origin. I'm going down 1, 2, 3, 4. So I have negative 4 as the y-coordinate. And yes, both coordinates are negative, just like with this point. We expected that. Finally, to this one, let's go fast now. We're getting good at it. Let's go fast. This point is 1 unit to the right of the origin. So it is going to have an x-coordinate of 1. And it is 1 unit below the origin along in the up-down direction, y-axis direction. So it is going to have negative 1 as its y-coordinate. X-coordinate positive, y-coordinate negative, just like this one. We see the pattern. Okay, we can identify points on the coordinate plane. Let's now graph some points from a table of values onto the coordinate plane. But to do that, I'm going to have to do some erasing because this is starting to get very cluttered. Okay, using a nice new clean microfiber cloth, I'm going to erase all of these points, but I'm going to be careful not to erase my axes or my labeling. And that's pretty good. That's pretty good. Using a clean cloth helps. Okay, we are now going to graph points. Okay, is that going to be just as easy? Eventually it will be easy. But let's start with some fairly basic ones. We're going to start by graphing points. We'll graph a couple of points right here at the top of the values that we could have graphed on a regular number line back in the days when all we used was a regular number line. We didn't have a y-axis. So we know how to do that. 2, 0, the x is 2. Okay, so if the x is 2 and the y is 0, what does that mean? The x being 2 means from the origin I'm going to the right by 2. So 1, 2. So that goes this far. But then the y is 0. What does that mean? It means from the origin I am going 0 in the positive, negative direction, the up-down direction. So if I'm going 0 up, 0 down, it means I'm staying here. It means that this point's right on. I'll make this line bigger. This point is right on the x-axis like we're used to from the number line. 2, 0 is just a way of expressing what we would have earlier just thought of as 2. It's positive 2, so it's right there. But this isn't just a number line. This is a coordinate plane with both x-axis and y-axis. So it's good that we are given the y-coordinate. It's good that when that happens, we're given y-coordinate of 0, because that makes sense. It means I am going up, down by 0, which means I'm not going up or down. I'm staying right there at the height of the origin. Okay, that one's done. I will check it off. We have graphed that point. Let's find another one that has a y-coordinate of 0. Right here, negative 3, 0. Very similar. Negative 3. We were looking for negative 3 on the number line. If we just think of the number line, okay, well, negative 3 will be over here. And there's our dot. The fact that it has a y-coordinate of 0 is telling me not to go up or down. It's going to land right on the x-axis, and it does. So we're kind of used to this. We've seen this before. But it's happening because of the fact for both of these points, my y-coordinate was 0. Now things are going to start changing a little bit. Now this point has an x-coordinate of 0. So where do I start? I always start with the x, and the x is going left, right. Except I'm going 0 to the left, 0 to the right. So in the x direction, I'm not moving. I'm staying right here at the position of the origin. But the y direction, I am being asked to move. I'm being asked to move 4. It's positive 4, so I'm being asked to move 4 up from the origin. So 1, 2, 3, 4, and there's the point. The point 0, 4 is right here. And again, we start to see a pattern emerging. When the point in the table of values has a 0 in the y position, the point lands on the x-axis. And when it has a 0 in the x position, the point lands on the y-axis. And when you think about what these coordinate pairs mean, it makes sense. Okay, so let's do this one. This also has an x-coordinate of 0. X-coordinate of 0 means I'm not going anywhere left, right. I'm staying right here in the middle and at the left-right position of the origin, which is here in the middle. But I'm not graphing this point because I am also in the y direction being asked to go negative 2 down by 2. Negative 1, negative 2. Well, a little messy, but there you go. The point 0, negative 2 ends up here. And our patterns, again, are useful to us. They help us to realize that we must be doing it right. Whenever we have a point that has a y-coordinate of 0, it's going to land on the x-axis. Whenever we have a point that has an x-coordinate of 0, it's going to land on the y-axis. And can we identify these points? If we, for instance, are drawing on a graph that doesn't have graph paper, so it's not quite so easy to see everything perfectly as it would be if there was graph paper, will it help if we label the points? Well, quite often it does help. And if you have space, it can be good to label the points. So I'm going to label this point. Which point was this again? This is the point 0, 4. Here we have the point negative 3, 0. I'm using the same techniques I did when we identified all of those points previously. Here we have 0, negative 2. And here we have 2, 0. We don't want to be mixing up our x's and our y's. That's where things will go wrong and we will have mistakes. If I'm going too fast when I graph the point 2, 0, I could end up putting it here. That's not the point 2, 0. That's the point 0, 2. X first, then the comma, then the y. Okay, now let's start graphing some of these other points where we have some different stuff happening. And this is a very important one, 0, 0, because it happens a lot. It happens a lot in tables of values. For instance, if I give 0 milliliters of water to my plants, I shouldn't be surprised if they grow to be 0 centimeters or inches tall. So 0, 0 happens a lot in scientific experiments. When you give the plant 0 water, it grows 0 height. When you spend 0 time in the parking lot downtown, you expect to pay $0. That's the point 0, 0. It's a relationship. All of these are showing a relationship between the x and the y. So in that parking lot example, the x would be how much time was I parked for in that parking lot. The y would be how much money will I have to pay. But if I spend 0 minutes parked there, I'm not paying anything. So that's the point 0, 0. The point 0, 0 might look like a whole bunch of nothing, but it's not nothing. It's actually full of meaning. 0, 0 on the coordinate plane, when I graph it, I am going 0 in the left-right direction, so that's staying in the middle. But I'm also going 0 in the up-down direction, so that's staying in the middle. It means I'm graphing this point right here. And it's not easy to fit the labeling of it, but I'll manage. 0, 0 is right there. Okay, we can do this. That point 0, 0, very important. How about this next point? 4, 2. Okay, I'm saying it quickly, but the x-coordinate is 4 and the y-coordinate is 2. What do I do first? See me slowing down. First I do the x. I am going 4 along the left-right, which is the x-axis. Positive 4, it doesn't say negative 4, I'm going positive 4, so that means I'm going to the right. 1, 2, 3, 4. But I don't go and start drawing a dot, because first I have to check what's going on with the y-coordinate. Okay, so I have to remember that I went to the right by 4 from the origin to get here, but now I have to go up because it is a positive 2. I am going to go up by 2 from the origin. I'm not at the origin, I'm way over here, but I can still remember how high the origin is. So I'm going up by 2 from that height, from here, 1, 2, and I'm able to put my dot. Let's try and do this well. Again, it's hard to do well because of the angle. I'm looking at it from this angle, but you're seeing it from this angle. Am I even on camera? Yes, I am. And actually, I'm kind of impressed. For someone who can often be quite messy when he draws, I think I did a fairly good job of this. So that's the point 4, 2. I may as well label it. X is 4, Y is 2. Both of them positive. I'm not surprised because it's in this top right quadrant. Not so hard. But slow down and take your time. Think about what you're doing. Think about the steps. Don't try to do all the steps at once because that's where mistakes happen. Negative 1, 3. Let's graph that. Okay, he's coughing. You better take a sip of the fizzy water. That's good. Okay. X is negative 1, Y is 3. Same strategy. Slowly, carefully. X direction, that's left, right. Excuse me, that's left, right. I am going negative 1, I am going to here. But I don't stop here and draw a dot. I am going up by 3. From here, 1, 2, 3. And again, drawing it carefully, trying to draw it carefully. And stepping back here where I can see it. Not too bad, Doug, not too bad. I don't really have room to draw the brackets with the coordinate pair labeling over here, so I'm going to have to put it over here. What goes with this? Well, I can just copy it down from here without thinking very hard. Negative 1, 3. Close the brackets. Remember, an open bracket, a closed bracket, and a comma. You always do it this way. Don't forget. And what happened? Negative x coordinate, positive y coordinate. Up here in the top left quadrant, that's what keeps happening. Okay, I will check that off. 3, comma, negative 4. So looking at it in the table of values, I see the 3 and the negative 4 underneath the x and the y. But I know it means in my coordinate label, my coordinate pair label, I will have those round brackets, and first there will be a 3, then a comma, then a negative 4. And I see the relationship between what happens with these and what they look like in there, which isn't really very different. Let's face it. 3, negative 4. 3 means it's positive 3. So in the left-right direction, the x-axis direction, I am going to the right by 3. 1, 2, 3. But I don't stop here. Then I also check my y. Negative 4, down by 4. 1, 2, 3, 4. Really hard for me to see if I'm doing this straightly or crookedly. But I'll start my dot, and then I'll go over here. It's a little low, I'd say, so I'll just make it really big, but extending it in the positive direction. Okay. It's not great, but it's not too bad either. Okay, that was the point 3, negative 4, as I expected. Positive x value, negative y value, down here in this quadrant. The lower right quadrant, the fourth quadrant. Okay, now we have this one. Okay, now it's getting crazy. Negative 2, negative 2. They're both 2's and they're both negative. Now you can tell the teacher is trying to challenge you when you see this. Okay, all the things that are a little bit more difficult are happening all at once. Negative 2, negative 2. Does it phase us? No. We're not worried at all. Negative 2 means left, right. We're going to the left from the origin. Negative 1, negative 2. Then the other negative 2 means in the up-down direction, meaning down, it's negative. We're going down by 1, 2. It's right here. I wonder how many of the points I did in my first exercise where I was identifying coordinates, I'm using again here. I don't remember now. Okay, and it's not as easy to draw the labeling because the extra negative signs gives me more stuff to do, but negative 2, comma, negative 2, just managed to have space to put in that bracket. I got it in there. It works. It's fun. Okay, so let's do a few more. What I'll do is I'll erase all the ones that I've put, which is going to get a little bit more messy now because I have a bunch of dots right on my axes. Didn't have those in the first exercise. But I thought it was important to graph these points that involve the zeros as coordinates. So I will carefully erase those, and then I'm going to make up a few more points, but I'm just going to make them up as I go along. And I'm going to try to just look at it as a different way and approach it from a different way. How will I do that? We will see very soon. Okay, this thing, I think I may well be faster to just erase everything and draw it again, because drawing the lines for the table of values won't be very difficult. Leave room for quite a few points. There's room for at least 7 points. Now let's erase some of this. These ones are easy to erase because they're out away from the axes. So let's erase those. I can erase this label. Oh, this one I have to be careful. That negative sign was already a little too small anyway, so I'll make it a little bigger there. And erase this, erase that. Oh, I have to be careful getting in here into this corner. It is quite a fussy thing to do. And I do wish that I had actual graph paper on my wall, but I don't. Now I'm making a little bit of a mess on my axes because I need to get rid of these dots. Not too bad. Now let's tidy it up. You'll never do this when you're on your paper. You'll just draw another coordinate system lower down the page or on the next page. That's what you'll do. But with a chalkboard, we have sort of a different way of doing things. And it is getting a little bit more messy, isn't it? There, there, there. That one was bigger than it really needed to be. Oh, over here we have some tidying up to do. Quite a lot of it. Nearly done. And here. Okay, I think I'm going to avoid graphing points that are right on the axes, which means I'm going to avoid sticking zeros into this table. What I'm going to do though is I'm going to practice each of the 4 quadrants, the top right, the top left, the bottom right, separately. So up here, what was the pattern that we saw? Double check the time. We saw that over here, the x and the y coordinates are both positive. So let's do a few of those. How about 4, 3, and just for fun, let's do 3, 4. How about 2, 1? How about 1, 4? How many do I need? Do I really need 7? I don't think I need 7. How about 4, 4? And 1, 1. So we see that thing that happens when the x and the y coordinate are equal. What does that look like? In fact, I will also put 2, 2, just because that looks like fun in itself. Okay, now let's graph these. This should go fairly quickly. We know that we're always going in the positive direction. So from the origin, we're always going to the right or up. To the right for the x's and up for the y's. Not so hard. 4, 3. To the right by 4, up by 3. I'm going to put the dot, try to get the dot in the right place as well as I can. It's a little high, but it's good enough. And I'm not going to label it. I'm just going to put a bunch of dots this time. 3, 4, or wait, do I want to do that? 3, 4. I'm going to the right from the origin by 3 and then up from the origin by 4. That's putting me here, but let's try to do it so it's not too messy. No, you know what? I don't like the idea of just crowding a bunch of dots without labeling them. It's too early for us to be trying to do that. So that first one was 4, 3. This one is 3, 4. It is going to get crowded. 2, 1. X is 2, y is 1. You see how quick you get at doing this with a bit of practice. 2, 1. I'll try drawing these a little smaller. 1, 4. To the right by 1, up by 4. There we go. 1, 4. 4, 4. To the right by 4 and up by 4. Okay, that's going to be hard to put in place because the labeling for this previous dot is in the way. So I'm just canceling that one. Okay, 1, 1. 1, 1. Right by 1 from the origin, up by 1 from the height of the origin. Managed to label that. 2, 2. To the right by 2, up by 2. Okay. I really want... You know what I want to do? I'm going to move this label, this 3, 4 label. Move it out of the way by just sort of putting it a little higher. Oh, that's messy. 3, oh, very messy. I am reaching the limits of my abilities here. 3, 4, that's what that was. Because I've decided, after all, I do want to graph this point 4, 4. Just because I see an interesting pattern emerging. To the right by 4, up by 4. Now I have a spot I can fit it. Try to place that quite well. It's pretty good. And then you look at this 1, 1, 2, 2, and 4, 4 points. And you notice that they form a line. If I had done this more neatly on graph paper, it would be even easier to see. So that's interesting. Will we ever graph several points and have them all land in a line? Yes, we will. That will happen eventually in math. But we're not doing that yet. What we're doing now is we are practicing using a coordinate plane. We are practicing graphing points, and we are getting quite good at it, I think. So I will erase, I'm going to leave these here because they're not really in the way right now. But I'm going to erase these, and I am going to put a bunch more. I think because of all this clutter, I won't do 7 points for each quadrant. How about I do more like 3 points for each of the remaining quadrants? There. So, which quadrant should I work on? Should I go to this one, where my x coordinates will be negative, but not the y's? Should I go to this one, where my y coordinates will be negative, but not the x's? Or should I go to this one, where both the x and the y coordinates will be negative? I like that idea. I'm doing that one. How about negative 2, and negative 3, but I'll do negative 4, negative 1. Notice what they have in common is that all of them have both negative x and negative y, which is going to place them in this quadrant, because I see the patterns and I understand how this works. Okay, x of negative 2, y of negative 2. X of negative 2 to the left, negative 1, negative 2, and then y of negative 2 means down, negative 1, negative 2, and I put my dot, and I will label it small. Negative 3, negative 3. To the left, negative 1, negative 2, negative 3. And then down, negative 1, negative 2, negative 3. And that ends up being about here. Let's check that. It's not too bad. Negative 3, negative 3. And why did I want to choose these? Where the x and the y are equal to each other. But they're both negative, but they're still equal to each other. Negative 2 is equal to negative 2. And so I'm noticing that these two, kind of if it were drawn on a graph paper a little more neatly, would be more obvious. These two are forming a line with these other three that we did before. So that's interesting. That keeps on happening way down over here. That sort of what happens on one side happens on the other side thing, which we can refer to as being kind of symmetry, kind of mirror imagesness. That's the worst word I ever made up. Mirror image like. Makes sense. It makes sense because what did we do here? We made these two axes cross at right angles. We created a couple of mirrors, if you want, and we get to see symmetry happening in math. And then that overlap between math and art happens because symmetry is interesting. Interesting to look at and to appreciate. Okay, that's enough for those two, but I also want to graph this point. Negative 4, negative 1. Negative 1, negative 2, negative 3, negative 4, negative 1. I did it too fast, didn't I? On the x-axis, I am going to the 4 units in the negative direction, which means to the left from the origin. Negative 1, negative 2, negative 3, negative 4. Slow down, Doug. On the y-axis, from there, I am going down. It's negative direction, so I'm going down by 1. So negative 4, negative 1. It works. I'm glad I only did 3, though. All those extra negative signs, it's cluttery. Should I erase these? I don't have to. I'm just going to make this longer, and I'm going to add 3 more points to it. And I want to do, should I do this quadrant or this quadrant? I'm going to do this quadrant. What have I learned about this quadrant? The x's will be negative, but the y's will be positive. So let's make up some points where that happens. Yeah, negative 2, negative. Whoa, what are you doing? I put a negative 2 in there when I didn't want to. I said the y's would be positive. So negative 2, 2, that's what I intended to put. Okay, let's graph these. Negative 3, comma 1. X is negative 3, y is positive 1. We're getting good at this, aren't we? Negative 1, x is negative 1, y is 4, y is positive 2, 3, 4. Negative 2 for x, positive 2 for y. Negative 1, negative 2 for x, positive 1, positive 2 for y. It's starting to feel easy. I hope it's feeling easy for the students. Practicing this a lot is good. It's a worthwhile thing to do because, as I say, when students don't practice it enough, they're always a little bit foggy about it and they make little mistakes where a point that should be above the x-axis ends up below, or a point that should be on one of the axes ends up out here away from the x. Those mistakes happen when students haven't practiced this enough. I don't have enough room to extend this table any further, so now I'm going to erase it, but I am going to put 3 points on it that I will graph in this lower right quadrant, just because how could we leave it out? It wouldn't be fair to leave it out after putting all of this attention in these other 3 quadrants. So what happens over here? My x's will be positive, my y's will be negative. How about positive 4, negative 3, positive 3, negative 2, positive 2, negative 1. Okay, I followed my rule. Oh, I'm not even on camera. Who is this guy? Whose hands are these? Okay, now that I'm on camera, I followed my rule. My x's are positive, my y's are negative. But what else did I do? I made a pattern happen just for fun. 4, 3, 2. Those ones are gradually getting smaller by 1 unit at a time. Negative 3, negative 2, negative 1. Those ones are gradually getting larger, more positive, closer. They are moving in the positive direction by 1 unit at a time. So 1 unit at a time change, and this also has a 1 unit at a time change. Should that produce something interesting in our graph? Let's find out by graphing the points. X is 4, y is negative 3. X is 1, 2, 3, 4. Y is negative 1, negative 2, negative 3. So trying not to do this too crooked. How'd that go? It's not bad. X is 3, y is negative 2. X is 1, 2, 3. That's positive 3. Y is negative 2, negative 1, negative 2. So that's going to be about here. And then x is 2, y is negative 1. X is positive 2, y is negative 1. And I put a dot. And they're not really landing in a line very nicely, but I think they are supposed to. Yes, this one is not really in the best spot. I think it looks better if I put it there. And that's what happens when you're standing to the side of your graph as you're drawing. Interesting, they're falling in a line. But we don't have to be tested on lines yet. We're not doing lines, we're doing dots, we're doing points. But interesting things happen where you see patterns in the table of values and then you see what those patterns mean when you graph. Well, that's really why we're doing this. So that as we work through all the levels of math that we're going to learn, where we deal with all sorts of different shapes and curves on the coordinate plane, we're able to see what type of patterns happen in this table of values and how those patterns are reflected in the graph. So let's quickly label these. 2, negative 1, 3, negative 2, 4, negative 3. I am identifying points like I did at the very beginning. And I'm able to do it very quickly. Why? Because I'm getting good at this, and I'm getting good at it because I am practicing. Okay, I only have a little bit more that I want to go into. I don't have very much more time. But I'm going to have to do some erasing. This graph is very cluttered now. I'm going to erase the points in the table of values. I'm going to erase all of these dots and labels. But none of them happen to land right on the axes, so I don't have to do quite so much erasing as I did before. After all this work, he goes and he erases it all. It seems like a shame in some ways. It's a good thing I know how to graph because I can make a graph anytime I want now that I have this skill. Okay, let's add a few points. And we're not going to try to make this harder and harder and harder. We're going to do a bit of what-if experimentation though. Because when I work with students with the regular number line, we learn that we can graph some other points besides those ones that we've seen that are landing right on these numbers. What about this point? 1.5. We have a decimal. Our x-coordinate has a decimal. Let's do the easy part first though. The y-coordinate is 0. What happens? What's the pattern? When the y-coordinate is 0, what happens? It means we're not going up or down in the y direction. So the point lands right on the x-axis. So we're expecting this point to land on the x-axis. And that means it's like an old-fashioned number line question from way back before we knew y-axis could be used. But 1.5, that's halfway between 1 and 2. Can I graph that? I don't know. Let's try. 1, the x-coordinate is 1.5, and it is positive 1.5. I'm moving to the right from the origin, but 1.5 units. 1.5. I'm going halfway between this 1 and this 2. Okay, 1.5 comma 0 in the coordinate pair, in the table of values, can still be graphed. It's a bit of an estimate, 0.5 halfway, that's kind of easy to estimate, so I just by eye, I try and put my dot halfway between the 1 and the 2, and it works. How about negative 3.25 as my x, and y at 0 as my y. So, pattern. 0 as y means it's going to land right on the x-axis. It's not going to be above or below it because my y-coordinate is 0. But negative 3.25, negative 1, negative 2, negative 3, 0.25 is 1/4. 1/4 of the way between negative 3 and negative 4. Not quite as easy to make the dot land exactly where you want it. But with a bit of care and patience, you can do a fairly good job. When you see these, it's not necessarily so easy to understand what the coordinates must be because it's not landing right on these numbers. So maybe it's all the more important to label them. The point of what I'm doing is simply to point out to you that yes, when you get decimals in your table of values, you can still do it. You can still graph it. Again, whenever anything is a little different, slow down. So I slowed down, and I'm going to label this one as well. Negative 3.25. Now, someone looking at the graph before I did this might guess something a little different. They might think it looks like negative 3.2 or negative 3.3, but this label makes it clear. It's meant to be negative 3.25. I just do my best to make it as clear as possible because graphs are meant to be seen. They're meant to be visually clear. So I'll do whatever it takes to make it clear. The math I'm trying to transmit into the eyes of the person who looks at the graph later. There's decimals. We're able to graph these. How about fractions? This is a mixed number. Well, I had room to put that a little closer into the table here. Do that. Negative 2.5, and I still have a y coordinate of 0. So because I've gone into this different territory where I'm putting decimals and not fractions, I'm trying to keep it from being too crazy simply by keeping the y equal to 0 for now. For now. Negative 2.5, 0 is going to be halfway between negative 2 and negative 3. If I know my fractions, I know that. Negative 1, negative 2, negative 2.5, 0. It's cluttered. Negative 2.5, 0. It's not really different from graphing the one that was decimals. So let's do one last one. These are little challenger ones. How about positive 1/2, 3. Okay, no 0 involved this time. Positive 1/2 is only halfway between 0 and 1. It's positive, so I'm going in this direction. So halfway. And then, the y is 3 though. 1, 2, 3. I'm able to do that as well. And that is as challenging as I want to get in this lesson. Thank you very much for being patient and watching me do this. It is fun, and it is worth spending some time on. So do not fall victim to the temptation of saying, this is easy, I could do it all in 5 seconds. Take your time, do a lot of practice, try experimenting a little bit, look for patterns, and I will see you next time.